Ask whether intelligence declines with age, and the honest answer is, it depends entirely on which kind of intelligence you mean. Some cognitive abilities peak in your 20s and gradually decline. Others continue improving well into your 60s and 70s. Understanding this split resolves one of psychology's most persistent public misconceptions about aging and the mind. Fluid intelligence, encompassing raw reasoning ability, processing speed, and the capacity to solve novel problems without relying on acquired knowledge, shows a developmental trajectory that typically peaks in the early to mid-20s and then gradually, gently declines across the remaining adult lifespan, with processing speed showing the most consistent and earliest measurable age-related decline of all cognitive abilities studied. This decline is generally gradual rather than precipitous for most healthy adults, becoming more noticeable primarily in advanced old age rather than in middle adulthood. Crystallized intelligence, encompassing accumulated factual knowledge, vocabulary, and learned skills built up through education and life experience, shows a strikingly different developmental trajectory, continuing to increase gradually through much of adulthood and often remaining stable or even continuing modest growth into a person's 60s and 70s, before showing more noticeable decline only in very advanced old age or with the onset of significant cognitive impairment. This explains why vocabulary and general knowledge tests often show older adults outperforming younger adults, even as those same older adults show slower performance on timed reasoning tasks. Much early research on cognitive aging relied on cross-sectional designs, comparing different age groups at a single point in time, which risks confounding true age-related change with cohort effects. Systematic differences between generations in average education, nutrition, healthcare access, and general environmental enrichment, unrelated to the aging process itself. Because each successive generation has, on average, benefited from more education and other cognitive enriching environmental factors, cross-sectional studies comparing generations tend to overstate the true magnitude of age-related cognitive decline compared to more rigorous longitudinal designs following the same individuals over time. K. Warner-Shea's Seattle Longitudinal Study, one of the longest-running studies in psychology, has tracked the same cohorts of individuals across multiple cognitive abilities for over 5 decades, finding considerably more modest age-related decline in most cognitive abilities than earlier cross-sectional research had suggested, with most people showing little to no measurable decline in several abilities until their 60s or later, and substantial individual variation in the rate and timing of any decline that does eventually occur. Longitudinal research on cognitive aging has identified several factors consistently associated with better maintained cognitive function into later life, including continued formal or informal education throughout adulthood, occupations involving ongoing cognitive complexity and challenge rather than routine or repetitive tasks, sustained social engagement and relationships, which appear to provide both cognitive stimulation and buffering against stress-related cognitive decline, and regular physical exercise, which supports cardiovascular health directly linked to brain health and neurogenesis. Cognitive reserve theory proposes that lifelong intellectual engagement, education, and cognitively stimulating experience build a kind of buffer or reserve capacity that allows some individuals to continue functioning normally despite age-related or pathological brain changes that would produce clear impairment in individuals with lower reserve. This theory helps explain the previously puzzling finding that the degree of measurable brain pathology, including in dementia, does not always correspond tightly to the degree of clinical cognitive impairment observed. Reserve capacity substantially moderates the relationship between brain changes and their functional expression. Intelligence does not simply decline uniformly with age. Fluid and crystallized abilities follow genuinely different trajectories, and rigorous longitudinal research reveals far more stability and individual variation than older cross-sectional studies suggested. How we age cognitively is shaped substantially by education, engagement, and lifestyle factors within our control, not solely by the passage of time.